Let's look at some optimization applied to health. Approximately 1 in 4 deaths in America is caused by heart disease. A study has been conducted to see if the common goal of 10,000 steps per day is truly best for reducing risk of heart disease. So, when you get like a Fitbit or something, they encourage you to hit 10,000. And I think the Garmin does the same thing. A lot of the watches will automatically do a celebration if you hit 10,000 steps. We want to see if that's actually the amount of steps that you should be going for to reduce risk of this heart disease in America that seems to be killing 1 in 4 people. So the study is assuming that the average person can only take up to 25,000 steps in a day. If you've ever done 25,000 steps and you've tracked it on a watch, that's quite a bit. We're not going to tell people, walk 50,000 steps a day. Just don't sit down at all, and then your heart's going to be healthy. So we need to be realistic. We have a max amount that we could ever tell somebody to take in a day. The number of deaths from heart disease, D in thousands, is related to X, 10,000 steps. So if we plug in 2, that doesn't mean 2 steps, it means 2 times 10,000. It would mean 20,000 steps. So we want to be careful with these different units here. So plugging in 4 would mean 4 times 10, that would be 40,000 steps. And when we get out a number, if we get D is 12, that doesn't mean only 12 people died of heart disease. That unfortunately means 12,000. So we have both units are in thousands. And D of X is 5x squared minus 12x plus 610. Find the number of steps required to minimize the death rate. We want to make it as small as possible. We're going to find the absolute min. So our objective function that we're trying to minimize is this D of X. This is what we're going to take the derivative of, find any critical numbers for, and then we want to place them on our interval of interest. So the interval for this one, we want to think of the least and the most amount of steps that we could take. So the interval that we're interested in, well, the least amount of steps you can take is 0. Not a healthy choice, but you can't go any less than that. And then we're assuming the max amount that they would ever take is 25,000 steps. But remember, X is supposed to be in tens of thousands. So we need to take that 25,000 and divide it by 10,000. And we get 2.5. So there's our interval of interest. It's not 0 to 25,000 because it's in units of 10,000. So if we did all the way to 25,000, that would end up being 25,000 times 10,000. That'd be way too many steps. So we have 0 to 2.5, which stands for 2.5 times 10,000 is 25,000. All right, we have our setup. Now we're going to find our critical numbers in our first step. What makes the derivative equal to 0? So d prime of x. We're going to take the derivative of 5x squared to be 10x, and then derivative of negative 12x is negative 12. Derivative of 610 is 0. So we have our derivative, 10x minus 12 is 0, and we want to solve that. This is an mx plus b situation where you have a linear function. All you want to do is get x by itself. So first thing I would do is add that 12 over. We want to get x by itself. So add 12, and then we want to divide by 10. We don't want 10 times x. We just want x by itself, which is going to be 12 over 10. And you could reduce that to be 6 over 5, or if it comes out to be a nice decimal, we'll do that. It's 1.2. So we're telling them to reduce risk of heart disease, take 1 and 0.2 steps. No. Remember our units. How many steps are we really telling them to take? If you multiply that by the 10,000, the units that we're in, we're saying, hey, maybe the answer is take 12,000 steps. So our second step is to look at that interval of interest, start with our lower bound, d of 0, least amount of steps, to the most amount of steps is 2.5, 10,000, so 25,000. And then we can test 1.2, which really stands for 12,000 steps, and see what the risk of heart disease is. So we're going to plug back into the original function to compare some y values. So if you plug in 0, 5 times 0 squared minus 12 times 0 plus 610, plugging into our original function, you're going to get 610 out. And unfortunately, that doesn't just mean 610 people die from heart disease. Remember, our units can multiply by 10,000. That means 610,000 deaths. If we compare to plugging in 1.2 into this original function, 5 times 1.2 squared minus 12 times 1.2 plus 610, we're going to get 602.8. We need to multiply that by our units. And so that really stands for 602,800 deaths. And lastly, so between taking 0 steps and 12,000 steps, it's better to take 12,000 because the death rate went down for that. But lastly, what if we say, you know what, do the best you can, try to hit that 25,000 steps, which is quite a bit, every single day. What's going to happen to the death rate? When I plug in 2.5 into the original function, I'm getting 611.25 times 10,000. So it's going to be 611,250 deaths. So what's our conclusion? Well, it's looking like that critical number has the absolute minimum here. So we're going to say people should walk 12,000 steps per day to minimize heart disease deaths. Right? That's what the question asks. It says, find the number of steps per day to minimize the death rate from heart disease. So it doesn't ask for the actual minimum death rate. It just says, how many steps should we be recommending? So it seems like that 10,000 step goal is kind of random in reference to this study, in reference to heart disease, because our endpoints are 0 to 25,000, and our critical number isn't even 10,000. It ends up being 12,000 steps per day would absolutely minimize the death rate of heart disease.